What you're seeing on your screen right now is close to what the world might look like in 2075. I'm showing you these clips for visualization, and while they are obviously AI generated, you get the point. We are looking at a transformation so radical that it defies our current imagination. But this isn't just a collection of random guesses. I have mapped out a whole timeline of how we get to this reality. In this video, I'll be explaining how technology advances almost year by year, showing you the step-by-step evolution from the smartphone in your pocket to the total transformation of the human species. I truly believe we are the last generation that will ever live a natural human life. It's a sobering thought, but the next few decades will hold more change than the last 1,000 years combined. And in the next few minutes, you are going to witness the end of the world as you know it. For the last 20 years, we've been obsessed with a black mirror in our pockets. We've traded our posture, our attention, and our presence for a 6-inch display. But as we cross into 2026, that era is beginning to collapse. We are entering the age of invisible computing. By 2028, the smartphone will no longer be the center of your digital universe. It will become a secondary brain that stays in your pocket while the interface moves to your eyes. We aren't just talking about bulky headsets. We are talking about neural-linked eyewear that looks indistinguishable from a standard pair of glasses. This is augmented reality in its mature form. It's not a game, it's a layer of reality. Imagine walking into a grocery store and having your glasses highlight the exact ingredients for a recipe you looked up this morning. Imagine a world where language barriers vanish because real-time captions appear under the person speaking to you. But the interface isn't just moving to your eyes, it's moving into the walls around you. This is ambient computing. By 2030, your home won't wait for a command like "Hey Siri" or "Alexa." Using a mesh of low-power sensors and multimodal AI, your environment will sense your intent. It knows you're tired because it tracks your gait and heart rate. It knows you're frustrated because it recognizes the micro-expressions on your face. The technology becomes a ghost, always present, never seen. Between 2030 and 2035, the general-purpose humanoid will transition from a laboratory curiosity to a commercial reality. Companies like Tesla, Figure, and Boston Dynamics will move past the prototype stage, releasing units capable of navigating a cluttered human environment as easily as we do. They won't just be building cars, they will be folding laundry, unloading dishwashers, and organizing warehouses that were designed for humans, not machines. This shift is powered by end-to-end learning, a process where the robot watches a human perform a task and, within minutes, understands the physics and logic required to replicate it. And when the cost of labor is reduced to the price of electricity and a monthly software update, the definition of work changes forever. By 2035, seeing a humanoid robot walking down a sidewalk or stocking a shelf at a local market will be as common as seeing a delivery van today. We are no longer the only species on Earth capable of complex physical labor. The tools have started to move on their own, and the question is no longer if they will replace us in the physical world, but what we will choose to do once they have. The one-size-fits-all era of healthcare will come to an end. We are entering the biotech frontier. The catalyst for this shift is the maturity of CRISPR gene editing and the industrialization of mRNA technology. By this decade, the same platforms that delivered the first rapid vaccines will be used to create personalized cancer treatments. Instead of generic chemotherapy, doctors will sequence your specific tumor and, within days, print a custom-coded therapy that teaches your own immune system to hunt and destroy only the malignant cells, leaving healthy tissue untouched. By 2038, the focus will shift toward the ultimate medical challenge: longevity. Scientists will have identified the key hallmarks of aging, the biological errors that accumulate over time. We will see the first generation of senolytic drugs, therapies designed to clear out zombie cells that cause inflammation and decay. Longevity will no longer be seen as a luxury for the ultra-wealthy, but as a standard of preventative care. The goal isn't just to live longer, but to extend the health span, the period of life spent in peak physical and cognitive condition. By 2040, your medical record won't just be a list of past illnesses. It will be a living digital twin, a high-fidelity simulation of your biology that lives in the cloud. Before you ever take a new medication, your doctor will test it on your digital twin first, predicting every side effect and outcome with near-perfect accuracy. Between 2040 and 2045, the total dominance of solid-state batteries will begin. Unlike the lithium-ion cells of the early 2000s, these batteries are non-flammable, charge in seconds, and have double the energy density. By 2042, every vehicle, from long-haul cargo planes to local delivery drones, is powered by these solid blocks of high-density energy, effectively ending our reliance on liquid fuels forever. But the true turning point, the moment that will be recorded in history books for 1,000 years, occurs when the first commercial nuclear fusion reactor finally goes online. In the early 2040s, the engineering likely finally catches up to the physics. Using high-temperature superconducting magnets and AI-managed plasma control, we finally achieve Q-total, a state where the reactor produces significantly more energy than it consumes to run. We have successfully put the sun in a bottle. Unlike traditional fission, fusion produces no long-lived radioactive waste and carries zero risk of meltdown. Its fuel is deuterium and tritium, elements we can extract in near-limitless quantities from seawater. By 2045, the fundamental premise of human economics begins to shift. For all of recorded history, energy was a scarce resource. It was something we fought over, mined for, and rationed. But as the first generation of fusion plants begins to power entire regions, we enter the era of energy abundance. When energy becomes too cheap to meter, everything else becomes cheaper. Clean water becomes infinite through mass desalination. Vertical farms can run 24 hours a day, providing food for billions at a fraction of today's cost. Carbon capture facilities can finally run at the scale necessary to start reversing the climate damage of the previous century. By 2045, our relationship with AI shifts. We are no longer just using AI. We are witnessing the emergence of Artificial General Intelligence, or AGI, a system that can perform any intellectual task a human can, and many that we cannot. This decade marks the moment when AI begins to design its own successors. When an intelligence is capable of improving its own architecture, the speed of progress moves from exponential to instantaneous. This is the feedback loop. Every breakthrough in chip design or algorithmic efficiency is immediately applied to making the next version of the AI even smarter. In this period, months of human-level research are compressed into seconds. By 2048, the global economy is largely autonomous. Scientific discovery is no longer led by humans in labs, but by AI clusters that can simulate billions of chemical reactions and physical configurations in a single afternoon. We find ourselves in a strange paradox. We are surrounded by miracles, cures for diseases we haven't even named yet, and materials that defy the laws of traditional physics, but we no longer fully understand how they work. The black box of AGI becomes the primary engine of civilization. As 2050 nears, the boundary between user and program begins to blur. We stand at the edge of a new era where the definition of intelligence is no longer tethered to biology. The singularity isn't an event that happens on a specific day. It is a transition into a world where the future is being written by a mind that isn't ours. We are about to find out if we are the masters of this new intelligence or merely its predecessors. By around 2052, the Earth is no longer our only home. The technological foundations laid in the first half of the century, AGI, fusion energy, and advanced robotics, have finally made the harsh vacuum of space a viable workplace. We have begun the transition from a planetary species to an interplanetary one. The decade begins with the formalization of the Lunar Gateway. The Moon is no longer a destination for flags and footprints, it is a bustling industrial hub. Because of its low gravity, the Moon has become the primary shipyard for the solar system. Massive electromagnetic railguns, powered by lunar fusion plants, launch raw materials and processed fuel into orbit at a fraction of the cost of launching from Earth. By 2055, the first permanent human settlement on Mars. This is made possible by autonomous terraformers, swarms of AI-driven robots that work 24 hours a day to extract oxygen from the Martian regolith and build pressurized habitats deep underground to protect settlers from cosmic radiation. Life on Mars in the late 2050s is a testament to human resilience. These pioneers aren't just scientists, they are the first Martians. Children are being born who will never feel the heavy pull of Earth's gravity or breathe unfiltered air. They live in sprawling lava tube cities, illuminated by artificial sunlight and fed by massive hydroponic gardens. As we reach 2060, the Great Expansion is in full swing. Private corporations and international coalitions are already looking toward the asteroid belt, eyeing the trillions of dollars worth of platinum, gold, and rare earth metals locked inside orbiting rocks. By 2062, we are entering the era of the neural bridge. For years, brain-computer interfaces, or BCIs, were medical tools used to restore sight to the blind or movement to the paralyzed. But by 2062, the technology moves into the mainstream. This isn't about plugging in a cable. It's about high-bandwidth, wireless synchronization between biological neurons and synthetic ones. The primary shift is the non-invasive link. Using microscopic sensors that can be delivered through the bloodstream, we can now interface with the motor and sensory cortex without surgery. Communication begins to move beyond the speed of speech. We are entering the age of collaborative cognition. You no longer search for information, you remember it. The sum of human knowledge, curated by AGI, becomes a layer of your own thought process. By 2065, this bridge allows for something even more profound, the sharing of experience. We can now transmit sensory data directly from one mind to another. You can feel the cold wind of a Martian plateau from your living room on Earth. You can experience the muscle memory of a master pianist or the tactical intuition of a veteran engineer. Education is transformed from years of study into minutes of neural downloading. But by 2070, we have reached a state of digital immortality, where our thoughts, personalities, and memories can outlive our biological shells. The human story, which began in caves and forests, has finally migrated into the architecture of the light itself. Crazy to imagine, but by 2070, the convergence of every technology we have discussed creates the post-scarcity economy. The engine of this transformation is molecular assembly. Using advanced nanotechnology and the limitless energy provided by a global fusion grid, we have mastered the ability to rearrange atoms into any structure we desire. The factory of the future is no longer a massive building. It is a desktop device that can synthesize anything from a complex meal to a piece of high-end electronics, atom by atom, for essentially zero cost. When anything can be created anywhere, the global supply chain, the ships, trucks, and warehouses that once dominated our world simply vanishes. Intellectual property becomes the only remaining currency. We no longer buy things, we subscribe to designs. The concept of poverty, as it was understood in the 20th century, is functionally eliminated. When the basic requirements for a dignified life, clean water, nutritious food, housing, and healthcare cost nothing to produce, they become a universal human right. By 2075, work in the traditional sense is entirely optional. The robots from the 2030s and the AGI from the 2040s handle the maintenance of civilization. Humanity shifts toward a solarpunk reality, a world where high technology is seamlessly integrated with a restored natural environment. We spend our time on art, philosophy, scientific exploration, and the deepening of human relationships. We are no longer a species of consumers, we are a species of creators. The world in 2075 is unrecognizable to someone from the early 2000s. We have repaired the climate, ended hunger, expanded to other worlds, and merged our minds with the digital infinite. We have reached the end of our biological childhood. We are a mature, multiplanetary civilization, finally free from the chains of survival and ready to decide, for the first time in our history, who we truly want to be.